Suppose you have this data right here, and here to feed this data to a machine learning model. Let's say your machine learning model is right here. Now, most machine learning model, they require numerical input to perform computation. But if you look over here, your age is numerical, but your department and sex, these are not numerical. These are text in character, and more specifically, they are categorical in nature. Salary is numerical in nature. Now, for your machine learning model to perform effectively, some of them, they require that your data needs to be in a numerical format. So we are going to convert this data into a numerical format. That is called encoding. Proper encoding can improve the accuracy of your model. It can reduce your bias, and it also makes sure that your model is interpreting these columns correctly. Your department and sex and any other column that basically are category in nature. So there are different techniques to encode your categorical column. One of them is label encoding. In label encoding, what you do is you assign a unique integer to each category in your feature column. Let's understand this through an example. Suppose this is your data right here. This is already numerical. This is already numerical, but this one is not in numerical. So here, I'm going to see how many categories I have. I have HR, I have account. This will be a category one. This is another category, account. You can see that this one, and then you have sales. So there are essentially three categories. I'm going to assign 0 to HR. I'm just picking up a number. I'm assigning 1 to accounts. I'm assigning 2 to sales. This way, my data now gets transformed into this format. So my HR now, right here, they become 0. My account, this changes to 1. HR changes to 0. Your sales and account changes to 2 and 1 respectively. So now your data gets transformed into this format. Now this will be fed to your machine learning model. Let's take a look at another one. In this case, I have quantity, color, price. Color is categorical in nature. So let's say I assign red 0, I assign green 1, and I assign yellow as a number 2 right here. So my red is going to get transformed to 0. My green is going to get transformed to 1. Red is going to get transformed to 0, and so on and so forth. And this way, I can convert this column or this table into this format. And now a machine learning model can happily work with these numerical data. And then you have one hot encoding. Well, this one converts your categorical data into a binary format where each category values is represented by a separate column. In this new column, 1 will indicate the presence of the value and 0 would indicate absence of all other categories. So let's understand this through this example right here. I have this column, department, categorical in nature. So in this case, there are three different categories: HR, account, and sales. So one hot encoding is going to create three different departments for each one of these categories. It's going to create department HR, department account, and department sales. Now it's going to assign numbers to each one of them based on whether department HR, department account, or department sales is present. So let's understand this through this first record right here. So your age is 31, 31. Now in this case, your department is HR. So because the department is HR, your department HR right here, this is going to turn into 1. And rest of these columns, this is going to be 0 and this is going to be 0. Salary, 1,000 and the salary, 1,000. That remains the same. Next record, 52, age 52, age 52. In this instance, your department HR is present. There's a department HR. So we're going to say 1 over here. This will be 0, this will be 0. And your salary will remain the same as this number right here, 50,000. 50,000. Now let's go to the next one, 23, 23. In this case, your department is account. So coming back over here, your department account, which is this one, this is going to become 1. And these two columns, department HR will be 0 and your department uh, sales would be 0. So this will be 1. And then this 10,000 would be your salary, which is this right here. Next one, HR. In this case, come back over here again. Where is your HR? But department HR is over here. This is going to become 1 and this one will become 0 and 0. And this remains 30,000, which is this right here. And same thing with your 55. This is sales. So in this case, department sales, that would be right here. This is going to become 1. This is 0 and 0. And this will be 55, which is your age right here. And this is 70,000. That is this salary. Now in this one hot encoding, you will notice that the number of columns have gone up. Over here, you had 1, 2, 3 columns. Now you have 1, 2, 3, 4, 5. You have these 2 additional columns right here. Now in one hot encoding, suppose you have a categorical column with only 2 values. Then after you perform your one hot encoding, you can safely drop one of the column to avoid duplicate information. And this way you can reduce dimensionality. So let's understand this through this example right here. So let's say I have this data right here. And in this case, this particular column has only 2 values, male and female. So this is going to produce, a, after one hot encoding, it's going to produce this column and it's going to give you this column, sex male and sex female. Now, whatever information is present over here, you can derive this information from this column, right? If you look over here, if this is 1, this is going to become 0. If this is 1, this is 0. If this is 0, this is 1. So whatever the numbers are over here, this is going to be opposite of that. So since all the information that is contained in here can be derived from this column, you really don't need this column right here. You can drop either this one or you can drop this one. In this case, I choose to drop sex female. And now you will have this column right here. So how is one hot encoding better than label encoding? Well, your label encoding approach, it can create problem because it might suggest an order or a ranking among categories that do not actually exist. For example, take a look at this data right here. If I assign 0 to red, 1 to green, and 2 to yellow, that could make your machine learning model think that yellow, this color, is greater than green or greater than red. Well, that doesn't make sense because this type of ranking does not really exist. So your machine learning model may interpret this way, and this misunderstanding, it can negatively affect the model's performance. So your one hot encoding, it solves this problem by creating a separate binary column for each of these categories. This way the model can see each category as distinct and unrelated to each other. So for example, this is your color right here. Now you can create, there are 3 different types of colors: red, and then green, which is this one, and then the third one is yellow, that is this one. So you will have 3 columns: color red, color green, and color yellow. And each one of them will contain 1 and 0 depending on whether that color is present or not. So when do we prefer one hot encoding over label encoding? Well, first of all, when your categories are nominal. In other words, there is no intrinsic order in your categorical values. For example, red, yellow, green, the one we just saw. So in this case, you actually encode this into using one hot encoding and you'll get this data right here. So this is what you will work with now. When your number of categories is small to moderate, in that case, one hot coding is preferable. That's because your one hot encoding, it creates a new column for each category. So if your number of categories are small, that means your number of columns that will be created would be smaller. Let's take a look at this example. Let's say you have a data, rain, size, and city. And if you have, let's say, only 3 cities, then in this case, it's going to create 3 columns right here: city Delhi, city Tokyo, city Moscow. But now let's say you have hundreds of cities, 300 cities, let's say. If you have 300 types of cities, this is going to create 300 different columns. Now, you would prefer one hot encoding over label encoding when you're using a machine learning model that assume numeric distance has meanings. For example, your KNN, SVM, linear regression, neural network, they assume that your numerical distance has meaning. So label encoding would wrongly imply that one category is greater than another. For example, let's say this is my data right here, and I wrongly labeled it, and I'm using wrong label. I'm using red as 0, green is 1, and let's say blue is 2, red is 0, and green is 1. And let's say this is my data point X right here. And let's say this right here is my data point Y. And if I want to calculate distance between X and Y using my Euclidean, it will use this formula. So in this case, you can see that it is going to compare, it's going to look at this feature of color, and it's going to look at this color 0 and this 2, and it's going to use that 0 and 2 in order to determine how far or how close these 2 points are. And so this would not make sense. And that's because you cannot think red as greater than blue or blue greater than red, or you cannot think like red is further away from blue or blue is further away from red. So in this case, your label encoding, this would not make sense. You do not want to use label encoding. You want to use one hot encoding. So, when do you prefer label encoding over one hot encoding? Well, when your categories are ordinal. In other words, they have natural order. For example, low, medium, high. This could refer to low blood pressure, medium blood pressure, high blood pressure. So in this case, your label encoding, it is going to preserve ordinal relationship. Low, you can label as 0, medium, you can label as 1, and high as 2. So suppose this right here, this is your data. And in this case, this could be size of, let's say, shirt, and this could be price. So in this case, I can label S as 0, medium as 1, and label L as 2, large as 2. So this data now would get transformed into this right here. And you prefer label encoding over one hot encoding when your number of categories is very high. In other words, high cardinality. Well, that's because your one hot will create too many columns, making it computationally expensive. For example, in the case of zip code, user ID, or product SKUs, you want to use label encoding because your one hot encoding is going to create many columns. Now, you can prefer label encoding over one hot encoding when you're using tree based models. For example, decision trees, random forest, XGBoost, light GBM, and that's because they can handle encoded features pretty well. Now, these models do not rely on the numerical order as much since they split on feature values and threshold. So, in these instances, you can prefer label encoding over one hot encoding.